From the pragmatic engineer, designing data-intensive applications, the cloud, and doing the right thing. In 2016, Martin Kleppmann published Designing Data-Intensive Applications, which quickly became a go-to book for those of us building back-end applications and distributed systems. In it, Martin combined his experience as a startup founder with observations from his time at LinkedIn and invested years of rigorous, full-time research in the title. 9 years later, he felt the time was ripe for an updated edition, with cloud computing much more widespread than in 2016. So, Martin teamed up with software engineer and investor Chris Riccomini, a former colleague at LinkedIn and the author of The Missing README, for a full refresh of the book, which brings it right up to date for the present day. Martin was recently on the Pragmatic Engineer podcast, where we discussed this updated volume and many related cloud computing matters. We also looked into some topics that have become less relevant over time, like details on MapReduce. I asked Martin if this newsletter could share an excerpt of the updated edition of the book about a timeless, important topic, and he generously agreed. So, today we cover cloud versus self-hosting trade-offs, doing the right thing as a software engineer. These excerpts are only part of the book. The first edition has been on my shelf for years and is now in well-worn condition. I jumped at the chance to get the second edition, and if you're interested in building resilient systems, I recommend it as an excellent resource. My usual disclaimer: as with all my recommendations, I was not paid for this article, and none of the links are affiliates. See my ethics statement for more. The excerpt below is from Designing Data-Intensive Applications, 2nd edition, by Martin Kleppmann and Chris Riccomini. Copyright 2026, Martin Kleppmann, Chris Riccomini. Published by O'Reilly Media, Inc. Used with permission. This excerpt is from Chapter 1, Trade-offs in Data Systems Architecture. For anything that an organization needs to do, one of the first questions is whether it should be done in-house or outsourced. That is, should you build or should you buy? Ultimately, this is a question about business priorities. A common rule of thumb is that things that are a core competency or a competitive advantage of your organization should be done in-house, whereas things that are non-core, routine, or commonplace should be left to a vendor. 20. To give an extreme example, most companies do not fabricate their own CPUs, since it is cheaper to buy them from the semiconductor manufacturers. With software, two important decisions to be made are who builds the software and who deploys it. The spectrum of possibilities is illustrated in Figure 1-2. At one extreme is bespoke software that you write and run in-house. At the other extreme are widely used cloud services or SaaS products that are implemented and operated by an external vendor and that you access only through a web interface or API. The middle ground is off-the-shelf software, open source or commercial, that you self-host or deploy yourself. For example, if you download MySQL and install it on a server you control, this could be on your own hardware, often called on-premises, even if the server is in a rented data center rack and not literally on your own premises, or on a virtual machine VM in the Cloud Infrastructure as a Service, or IaaS. There are more points along this spectrum, such as taking open source software and running a modified version of it. A related question is how you deploy services, either in the cloud or on-premises. For example, whether you use an orchestration framework such as Kubernetes. However, choice of deployment tooling is beyond the scope of this book, since other factors have a greater influence on the architecture of data systems. Using a cloud service rather than running comparable software yourself essentially outsources the operation of that software to the cloud provider. There are good arguments for and against this approach. Cloud providers claim that using their services saves time and money and allows you to move faster compared to setting up your own infrastructure. Whether using a cloud service is actually cheaper and easier than self-hosting depends very much on your skills and the workload on your systems. However, if you already have experience of setting up and operating the systems you need, and if your load is quite predictable, i.e. the number of machines you need does not fluctuate wildly, then it's often cheaper to buy your own machines and run the software on them yourself. 21. 22. On the other hand, if you need a system that you don't already know how to deploy and operate, adopting a cloud service is often easier and quicker than learning to manage the system. Hiring and training staff specifically to maintain and operate the system can get very expensive. You still need an operations team when you're using the cloud, but outsourcing the basic system administration can free up your team to focus on higher-level concerns. Outsourcing the operation of a system to a company that specializes in running it can potentially result in better service, since the provider gains operational expertise from providing the service to many customers. On the other hand, if you run the service, you can configure and tune it to perform well on your particular workload. A cloud service would likely be unwilling to make such customizations on your behalf. Cloud services are particularly valuable if the load on your systems varies a lot over time. If you provision your machines to be able to handle peak load, but those computing resources are idle most of the time, the system becomes less cost-effective. In this situation, cloud services have the advantage that they can make it easier to scale your computing resources up or down in response to changes in demand. For example, analytical systems often have extremely variable load. Running a large analytical query quickly requires a lot of computing resources in parallel, but once the query completes, those resources sit idle until a user makes the next query. Predefined queries, for example, for daily reports can be enqueued and scheduled to smooth out the load, but for interactive queries, the faster you want them to complete, the more variable the workload becomes. If your dataset is so large that querying it quickly requires significant computing resources, using the cloud can save money as you can return unused resources to the provider rather than leaving them idle. For smaller datasets, this difference is less significant. The biggest downside of a cloud service is that you have no control over it. If it is lacking a feature you need, all you can do is politely ask the vendor whether they will add it. You generally cannot implement it yourself. If the service goes down, all you can do is wait for it to recover. If you are using the service in a way that triggers a bug or causes performance problems, diagnosing the issue will be difficult. With software that you run yourself, you can get performance metrics and debugging information from the operating system to help you understand its behavior, and you can look at the server logs. With a service hosted by a vendor, you usually do not have access to these internals. If the service shuts down or becomes unacceptably expensive, or if the vendor changes their product in a way you don't like, you are at their mercy. Continuing to run an old version of the software is usually not an option, so you'll be forced to migrate to an alternative service. 23. This risk is mitigated if alternative services expose a compatible API, but for many cloud services there are no standard APIs, which raises the cost of switching, making vendor lock-in a problem. If the cloud provider is in another country and a political conflict arises between that country and your own, you risk being locked out of the service due to imposed sanctions. The cloud provider needs to be true.